When people think about the strangest places in the universe, their minds usually drift outward, toward distant galaxies, alien planets, and stars thousands of light years away. But some of the most unfamiliar, eerie, and downright unsettling environments aren't light years from Earth at all. They are beneath your feet. Right here on our own planet lies a realm so extreme, so alien, that even today we've explored only a fraction of it. A place with no sunlight, crushing pressure capable of destroying submarines, and temperatures hovering just above freezing. A place that feels closer to science fiction or cosmic horror than to the beaches and coastlines we know so well. Despite these brutal conditions, this world is anything but empty. The deep ocean is teeming with life. Life that evolves in ways that challenge everything we think we understand about biology, survival, and what a living creature is supposed to look like. As you descend deeper into the water column, animals begin to look less familiar and far more disturbing. Eyes grow massive or disappear entirely. Bodies stretch, warp, and become translucent. Mouths expand to absurd proportions. Skin glows. Teeth curve inward like traps. And behaviors that seem impossible or horrifying become not just normal, but necessary. So why does life get creepier the deeper you go? What is it about the deep sea that produces some of the strangest organisms ever discovered? And why do these creatures inspire such a powerful mix of fear, awe, and fascination in us? To answer that, we need to dive. The ocean's first dark frontier, the Twilight Zone. The descent into strangeness begins sooner than most people expect. At around 200 meters below the surface, we enter the mesopelagic zone, more commonly known as the Twilight Zone. This region extends down to about 1,000 meters, and while it isn't completely dark, sunlight here is weak, filtered, and fading fast. Color behaves differently at these depths. Red light, having the longest wavelength and the least energy, disappears first. That means anything colored red effectively turns black, blending seamlessly into the surrounding water. Many animals exploit this quirk of physics. By evolving red pigmentation, they become nearly invisible in their environment. To us, illuminated by submersible lights, these creatures look startling and vivid. But to predators and prey living down here, red is camouflage. One of the most iconic residents of this zone is the vampire squid. At first glance, it looks like something out of a nightmare. Deep red skin, enormous reflective eyes, webbed arms lined with spine-like structures. The name alone conjures images of a bloodthirsty predator lurking in the dark. But the truth is far stranger and far more interesting. Despite its ominous appearance, the vampire squid is not a hunter at all. Unlike nearly every other squid or octopus species, the vampire squid is a detritivore, a creature that feeds on debris rather than prey. It survives almost entirely on something known as marine snow. Marine snow is a constant drizzle of organic material falling from the upper ocean. It's made up of microscopic dead organisms, fecal pellets, larval shells, bits of plankton, and decaying matter drifting downward like underwater snowfall. The vampire squid floats almost motionless at depths between 600 and 900 meters, conserving energy. Its metabolism is remarkably low, much slower than that of other cephalopods its size. Instead of chasing food, it waits. Using long, retractable filaments coated in sticky mucus, it collects particles of marine snow and slowly draws them in. It's a lifestyle perfectly suited to an environment where energy is scarce and meals are unpredictable. Its frightening appearance isn't about intimidation, it's about efficiency. Every strange feature has a purpose shaped by millions of years of evolution, but as you sink deeper, cephalopods abandon subtlety altogether. Far below the Twilight Zone lies a region so deep we've barely glimpsed it. This is where scientists have encountered the big fin squid, members of the genus Magnapinna. These are among the deepest living squid ever recorded, with sightings at depths exceeding 6,000 meters, deep enough to reach into the Hadal Zone, the ocean's most extreme layer. Bigfin squid look less like animals and more like something unfinished or incorrectly assembled. Their arms and tentacles can stretch up to 8 meters long, held rigid at sharp angles, giving the unsettling impression that the squid has elbows. Their mantles shimmer with an ethereal translucence, as if they're only partially solid. We still don't fully understand how they feed. Some scientists believe they drag their elongated limbs along the seafloor, snagging anything edible. Others think their arms passively collect food drifting through the water, much like nets. In a realm where food is rare and unpredictable, flexibility may be the most important survival trait of all. But scavenging isn't the only path to survival in the deep. In shallow water, many animals survive by filtering tiny particles from the water. But in the deep sea, where plant life doesn't exist and energy is precious, those same strategies often aren't enough. That's where things start to get weird. Take predatory tunicates, for example. Their relatives, sea squirts, are harmless, stationary filter feeders commonly found in shallow reefs. But some tunicates have adapted to life at depths of 600 to over 1,000 meters, and they've taken a much darker evolutionary path. These deep-sea tunicates resemble empty sock puppets drifting in the current. No eyes, no apparent features, just a wide, open mouth. That mouth isn't for filtering. When a small crustacean or invertebrate drifts too close, the tunicate snaps shut, trapping its victim inside. Digestion follows slowly, efficiently, silently. An even more unsettling transformation can be found in carnivorous sponges, the silent killers that don't move. Most people think of sponges as passive organisms, little more than porous bags filtering water for bacteria and plankton. Some are even harvested for use in showers. But deep in the ocean, sponges become something else entirely. Carnivorous sponges begin appearing around 200 meters and become increasingly common as you descend. By 6,000 meters, they dominate entire ecosystems. Instead of pores for filtering water, these sponges are covered in tiny hooks, spines, and spear-like structures. Small animals that brush against them become ensnared. Over time, the sponge slowly envelops and digests its prey. They don't chase. They don't react. They simply wait. Whether it's the harp sponge with its ribbed skeletal arms, or the bizarre ping-pong tree sponge with bulbous spheres branching outward, these organisms are proof that movement isn't required to be deadly. But not all deep-sea predators are so patient. Mouths bigger than bodies, the gulper eel. At depths beyond 1,800 meters, in the midnight zone, lives the gulper eel, a creature that looks like it was designed around a single absurd idea. What if your mouth was bigger than the rest of your body? The gulper eel's jaws are loosely hinged and capable of opening wide enough to swallow prey larger than itself. In a place where meals are rare and unpredictable, this ability can be the difference between survival and starvation. When threatened, the gulper eel can inflate its mouth like a grotesque balloon, making itself appear much larger than it really is. It's equal parts intimidating and strangely comical, but it works. And yet, even the gulper eel pales in notoriety compared to the deep sea's most infamous hunter. The anglerfish, predator perfected for darkness. Few animals capture the imagination like the anglerfish. There are hundreds of species, ranging from the relatively shallow to those found at depths nearing 6,000 meters. What unites them is their hunting strategy. A modified dorsal spine extends from their head, ending in a glowing lure called an esca. This light is produced by symbiotic bacteria living inside the lure, living flashlights powered by biology. In total darkness, the lure is irresistible. Unsuspecting prey swims closer, curious or confused, only to be engulfed by a mouth filled with inward-pointing teeth. Once caught, escape is nearly impossible. Anglerfish are capable of consuming astonishingly large meals. In one documented case, a fish weighing less than 9 grams was found to have swallowed over 12 grams of prey, more than its own body weight. Flexibility is everything down here. Jaws unhinge, stomachs stretch. Bodies adapt to feast whenever the opportunity arises. But not all deep-sea creatures rely on hunting alone. Some survive by becoming invisible. In the twilight zone, faint light from above creates silhouettes, outlines that predators can detect. Many animals counter this by using bioluminescence on their bellies, matching the dim glow from above and erasing their shadow. This strategy is known as counter-illumination. But some predators have learned to see through these tricks. One of the most astonishing examples is the barrel-eye fish, Macropinna microstoma. At first glance, it looks unreal. Its head is transparent. Inside are 2 large, tubular eyes that point upward, staring through a clear dome at the water above. This allows the fish to detect prey silhouetted against what little light remains. But for years, scientists were puzzled. The barrel eye's mouth points forward. How could it see its prey while eating it? The answer was even stranger than expected. The barrel eye can rotate its eyes forward, scanning through the front of its head as well as upward. The eyes can move through an arc of about 75 degrees. Humans, by comparison, can manage roughly 45. To replicate this ability, we'd need to look directly toward our own brain. This adaptation allows the barrel eye to track prey continuously, even as it lunges upward to strike. Still, all of this relies on at least a trace of light. What happens when there is none? In the deeper zones, where sunlight never penetrates, vision becomes optional. Some animals abandon eyes entirely. The tripod fish is a masterclass in adaptation without sight. It perches on the seafloor using elongated pelvic fins like stilts, holding its body upright. Its pectoral fins extend forward like arms, filled with nerve endings sensitive to vibrations and water movement. Instead of seeing prey, the tripod fish feels it. When something edible brushes past its sensory fins, the fish strikes. Efficient and precise. Vision simply isn't necessary. But even the tripod fish isn't living at the deepest edge of life. In a trench near Japan, scientists exploring one of the most extreme environments on Earth encountered something extraordinary. At a depth of 8,336 meters, they found a living fish. The deepest any vertebrate has ever been recorded. It was a hadal snailfish, a pale, scaleless, tadpole-shaped creature, barely holding its form against pressure that would instantly crush most machines. Little is known about this ghostly animal. Its environment is named after Hades itself, a realm of darkness, pressure, and isolation. Is it the creepiest creature in the ocean? Maybe not. But it is a reminder of just how far life can go. Deep-sea creatures disturb us because they violate our expectations. They don't resemble the animals we interact with daily. They live in environments so alien that we associate them with myth, hell, or the underworld. Until recently, we couldn't even observe them without robots. As air-breathing land mammals, we are drawn to light, clarity, and familiarity. The sky represents hope, possibility, and openness. The depths represent the unknown. But this fear is psychological, not biological. These creatures aren't monsters. They're survivors. Every bizarre feature, every glowing lure, transparent head, oversized mouth, is a solution to a problem posed by the most extreme environment on Earth. And these ecosystems aren't separate from us. The rivers we drink from, the climate we depend on, and the oxygen we breathe are all linked, directly or indirectly, to the depths of the ocean. What seems alien is essential. The deep sea shows us something important. Life doesn't just survive, it adapts. It twists, reshapes, and reinvents itself in ways our imagination struggles to keep up with. And while the ocean's depths may feel unsettling, they are a testament to evolution's creativity. In the end, the deep isn't creepy because it's wrong. It's creepy because it reminds us how small our understanding really is.